Lastly, I read data handling and statistics part and the probability concept of the probability. But today we have to discuss the next part, that is a part B. We have to discuss the probability distribution and probability density part. And the whole part is useful for the students and the readers and is useful for the research scholar students and most of the especially the BSc students, that is a mathematics honor students must and 12th standard students. The probability distribution and the probability density part, what are they? We have to discuss. Before discussion, we have to know about the whole details. What are they? First one is what is random variable, and there are two types, that is a discrete and continuous. And the second part, the probability distribution of a random variable for discrete, that is a probability mass function. Wow. Probability distribution function of a random variable for cumulative distribution function. Probability density function of a random variable for continuous function, that is a probability density function or simply density function or only density. Next one is a multivariate distribution. Next one is a marginal distribution. The next one is a conditional distribution. Next part is a mathematical expectation. Next is the moments. And the moments are the different, you have to find out the standard deviation, variance, Chebyshev theorem, marginal function, skewness and kurtosis, product moment, moments of linear combination of a random variable, conditional expectation, similar way mean, standard deviation, variance and etc. Next is special probability distribution. What are they? The discrete uniform distribution, mean, median, variance, moment generating function. Next one is a binomial distribution, exactly mean, variance, we have to find out the moment generating function. Next one is the negative binomial distribution and geometric distribution. And similarly special probability densities. For continuous case, for the probability densities, uniform distribution, gamma distribution, exponential distribution, chi-square distribution, beta distribution. And next one is some special distributions, Cauchy distributions, Rayleigh distributions, Pareto distributions, Weibull distributions. Next is the normal distribution. We have to find out the moment generating function and also mean. And next one is standard normal distribution and moment generating function on the standard normal distribution. We have to find out the limit n tends to infinity mzt equal to mxt. Normal distribution, bivariate distribution, normal distribution means the x and y are two random variables. That means we have to find out the covariance of x comma y. Conditional density of y equals to y given x equals to x. Similarly, conditional density of x equals to x given y equal to y. And the next one is the regression correlation. And the last part is limit theorems. Markov's inequality, Chebyshev inequality, sampling distribution, sample mean, sample variance, strong law of large numbers, central limit theorem, moment generating function. For higher theory, that is the stochastics process and the Markov chains. And there are the three models, the random walk model, gambling model, Chapman-Kolmogorov equation. Now, I discuss one by one. What is random variables? A random variable is a numerical or a real valued function defined on a sample space. Mathematically, a numerical valued function x of omega with domain sample space, that is omega, is written by omega belongs to that sample space such that omega tends to x of omega is called a random variable, where omega equals to 1, omega 1, omega 2, omega n. There are two types of random variable. The one is a discrete random variable, another is a continuous random variable. We have to discuss first discrete random variable. So, discrete random variable. Discrete random variable means the probability mass function you have to find out. A random variable x that can take on at most a countable number of possible values is said to be discrete. It is denoted by p of x equals to x or p of x or p of x equals to x or f of x. Very simple notation. And you have to remember always these symbols, then you will success. For a discrete random variable, define the probability mass function, that is P of A equals to P of x equals to A, and must be P of x greater than equals to 0, and for I equals to 1, 2, 3 dot dot. But P of x is equal to 0, otherwise the value of x. And the summation P of x must be 1. There are 5 conditions for the discrete random variable. Discrete means you have to summation, you have to find out that equals to must be 1. It is very important for that. Discrete case, one example is here. Whenever the function f of x equals to x plus 2 by 25, x equals to 1, 2, 3, 4, 5, then we have to find out the probability distribution of a discrete random variable and plot its graph. Whenever the f of x is equal to s plus 2 by 25, then f of 1 equals to 3 by 25, f of 2 equals to 4 by 25, f of 3 equals to 5 by 25, f of 4 equals to 6 by 25, f of 5 is equal to 7 by 25. That the whole summation equals to 1. That means f of x serves as the probability distribution of a random variable having range 1, 2, 3, 4, 5. So how can you find out the range of the random variable? We have to discuss next. Whenever the range is here and total the functional value of this whole summation equals to must be 1. So that's why we have to say f of x is a probability distribution of a random variable. What is the graph? A very simple graph. In x-axis, and this is the f of x. We have to take it f of 1, f of 2, f of 3, f of 4 and f of 5 and so on. And this is a purely that is a bar graph. Next one is a cumulative distribution of a random variable. How can you find out the cumulative distribution of a random variable? Very simple is f of x equals to p of x less than equals to x and summation t less than equals to x f of t, and x belongs to R. F of x is called the distribution function or the cumulative distribution of x. What is the conditional of cumulative distribution? Now, f of minus infinity equals to 0, f of infinity equals to 1. And if a less than b, then therefore f of a less than f of b. And a very simple example, 16. F of 1 is equal to 4 by 16. F of 2 is equal to 6 by 16. F of 3 equals to 4 by 16. F of 4 is equal to 1 by 16. From statistics, you have to find out the cumulative frequency. How can you find out the, suppose f of 0 is equal to 1 by 16, you have to add it, f of 0 plus f of 1. So automatically capital F of 1 equals to 5 by 16. Similarly, you have to add 3, automatically 11 by 16 and so on. So therefore, the distribution function is given by capital F of x equals to 0. First, x is less than 0. And the second one means 1 by 16, that is 1 by 16. And x lies between 0 and 1, left is closed. And next one is 5 by 16, there are two addition, that is a 5 by 16, x lies between 1 and 2 and left is closed. 11 by 16, x lies between 2 and 3, left is closed. And equals to 1 for x greater than equals to 4. That means that is a cumulative distribution function. We have to find out capital F of x. Exactly similar way, another example is to find the cumulative distribution function of the random variable if f of 0 and so on and plot its graph. Then similar way we have to find out a capital F of x, and that graphical method means that is a purely step function. This is a purely step function. That the cumulative distribution function seems to be a step function. Then how can you find out the range of a random variable? Random variable formula is f of x1 equals to capital F of x1. F of xi equals to capital F of xi minus capital F of xi minus 1. The cumulative distribution function is given by find PMF and probability distribution function and probability mass function. If the distribution function is already suppose given f of x. How can you find out the probability distribution of this random variable? So just alternate. Small f of 2, capital F of 2 minus f of 1. We have to find out the range 1 by 36. And the similar way f of capital F of 3 minus f of 2. Next one is capital F of 4 minus F of 3. Next one is capital F of 5 minus F of 4, and so on. Next go for the continuous random variable. The last one is discrete random variable. How can you find out the probability mass function, and how can you draw the cumulative distribution function? And now the continuous random variable. For continuous random variable, just the formula is P of x less than equals to x. You have to integrate, you have to minus infinity to x f of t dt, and that can be taken as capital F of x. Whenever the function is function, whenever the function not there, there is a probability density. Only we have to take it probability density. For continuous random variable, the probability of this x lies between a and b, left close, right close. Exactly the similar way, whenever the only the left equal and may be equal, right equal, or may not be equal. The condition is f of x greater than equals to 0, and integration must be minus infinity to infinity f of x dx equals to 1. It is the most important that greater than equals to 0 and integration must be 1. If a continuous random variable x has satisfies the probability density f of x is equal to k into e to the power minus 3x for x greater than 0 and equals to 0 elsewhere, then find k and probability of x lies between 0.5 and 1 left and right closed. How can you find out this? The f of x must be greater than 0, and we have to find out the integration minus infinity to infinity. And after that the integration, suppose k equals to 3. We know that for continuous random variable, the integration must be 1. So therefore, we have to find out the k. And after k, we have to find out the integration. 3 into e to the power minus 3 dx 0.5 to 1, because the probability 0.5 to 1. And after that, 173. That example can be taken as this way. Suppose we have to find out the k equals to 3. Then what is the f of x? Now f of x is equal to 3 into e to the power minus 3 as for x greater than 0 and 0 elsewhere. Then we have to find out the capital F of x. That means the probability density function. Integration minus infinity to x we have to take it, and f of t dt. And after that integration 1 minus e to the power minus 3x. Then what is the probability density function? Now f of x equals to 0 and x less than equals to 0. And another one, 1 minus e to the power minus 3x, x greater than 0. Then how can you find out the probability lies between 0.5 to 1? Now capital F of 1 minus capital F of 0.5. Exactly the value 0.173. Next one is the multivariate distribution. For bivariate case, x and y are two is discrete random variable. We have to take it exactly p of x equals to x, comma y equals to y. Other way, we have to take it exactly p of x, comma y. And probability by means of function, then you can take as the f of x, comma y. Then whenever the function can be taken, then f of x, y equals to p of x, comma y. Condition of a joint probability distribution function. Whenever the x and y are the two random variables, you have to find out the joint probability distribution function. You say that is joint. You have to take it joint, and the similar way the condition is f of x, y greater than equals to 0, and the summation must be 1. Cumulative distribution of x and y. Joint cumulative distribution, exactly same, capital F of x, y, p of x less than equals to x, y less than equals to y. So summation f of s, comma t, s less than equals to x, t less than equals to. A very simple example, we have to take it. Suppose f of 0 0 equals to 1 by 6, f of 1 1 equals to 1 by 6, f of 0 1 equals to 2 by 4, f of 1 0 equals to 1 by 3. We have to find out the joint cumulative. Cumulative means we have to find out the addition. So p of x less than equals to 1, y less than equals to 1. So f of 0 0, f of 0 1, f of 1 0, f of 1 1. So what is the sum? No, 16 by 18. That means 8 by 9. Continuous case. For continuous case, the joint probability density function. Capital F P of s, comma y belongs to A. That means the integration we have to take it. For discrete, that is a summation can be taken. But continuous, that the integration can be taken. F of xy equals to 3 by 5 into x into y plus x. X lies between 0 and 1 and y lies between 0 and 2 and equals to 0 otherwise. Then how can you find out the joint probability density function, you have to find out the cumulative distribution. How can you find out? Now P of xy belongs to A. P of x lies between 0 and 1 by 2, and y lies between 1 and 2. Then you have to integrate it. The very simple integration. Whenever you have to take the integration with respect to x, then y is constant. After that, you have to find out the last one, 11 by 80. Exactly, the cumulative distribution function for continuous function. The continuous exactly capital F of xy, P of x less than equals to x, y less than equals to y, integration minus infinity to y and minus infinity to x, f of st ds dt. A suitable example, if the joint probability density of x and y is given by f of xy equals to x plus y, x lies between 0 and 1 and y lies between 0 and 1 and equals to 0, otherwise, then how can you find out? Now, first one is that you have to find out the x less than 0 or y less than 0. Then capital F of xy minus infinity to y minus infinity to x, f of st ds dt. The answer becomes 0. Lies between 0 and 1 and y lies between 0 and 1. Then what is the capital F of xy? The capital F of xy equals to xy whole into x plus y. And similar way, case 3. For x greater than 0 and y lies between 0 and 1. We have to find out the capital F of xy. Half y into y 1 plus y. And also x lies between 0 and 1, y greater than 1. So now can you find out the capital F of xy? Now half x into x plus f of xy is exactly the same as 1. So what is the joint distribution function? The whole equals to 0. Second one is the half xy x plus y. Third one is the half y plus 1 plus y. Half x into x plus 1. Another is 1. And just a case, 5 cases. 1 minus e to the power minus y. For x greater than 0, y greater than 0. And equals to 0 otherwise. Like P of x lies between 1 and 3 and y lies between 1 and 2. A very simple formula, f of xy equals to del square by del x del y capital F of xy. This formula you have to take it. Very important formula, and del square f by del x del y you have to, very simple, you have to find out. And the joint probability density function f of xy automatically e to the power minus x plus y, another remaining is 0, x greater than 0 and y greater than 0 otherwise. So how can you find out the p? Probability of x lies between 1 and 3 and y lies between, so just you have to integrate, and integrate after the integration 0.074. And similar way, the three variables, 4 variables and n variable cases, other different definitions are there. Next one is a marginal distribution. For a discrete case, x and y are two discrete random variables. F of xy is the joint probability distribution. The marginal distribution of x at x can be taken as g of x, and similarly y, h of y. This is for all y f of xy, and here for all x f of xy. That is a summation can be taken for discrete, already said. And for continuous case, exactly same g of x, the integration minus infinity, and similar marginal density of y at y, h of y, that integration can be taken. There are two formulas, very important formula. For more than one variable, for discrete case, in this way, g of x1, so automatically x2 to xn. And for continuous case, exactly the integration can be taken, and suppose h of x2, there is a no x2 can be taken with respect to x. There is a dx1, dx3 up to dxn. There is a no dx2. Conditional distribution for discrete case, now f of x minus y, f of xy by h of y, comma h of y not equal to 0. Whenever x minus y, you have to take it x comma y. That is y in right side and y. Exactly, suppose f of y minus x, that means f of yx by h of x. Exactly same as f of x minus y is equal to f of xy by h of y, and so on. Simple example we have to take it. Given the joint probability density function f of xy 4xy, x lies between 0 and 1 and y lies between 0 and 1. and 0 otherwise. Find the marginal density of x and y and the conditional density of x given y equals to y. Suppose what is the marginal density of x? Of x equals to x. That means x equals to x means g of x is equal to minus infinity to infinity f of xy dy integration. Because x is there, so integration dy. So x is 4xy dy. 4xy dy. So answer equals to 2x. X lies between 0 and 1. Another one, g of x is 0 elsewhere. Similarly, marginal density of y suppose. So h of y can be taken. So h of y is 0 elsewhere. Another one, conditional density of x. How can you find out the conditional? Conditional f of x minus y suppose. So f of xy by h of y. Already f of xy is equal to 4xy. And by h of y. H of y, what is that? 2y. So 2y can be taken and answer is 2x. Similar way, f of y by x be also can be, you have to find out. And a variable also same as this. Suppose p of x3 minus x1 is to x4. So what is that? Now f of x1 is to x3 x4 divided by g of x1 is to x4. Similar way, this way you have to find out the definition conditional distribution of n random variable. For independent case, f of x1 is to up to xn equals to f1 x1 f2 x2 dot fn xn. For density case, exactly same f1 x1 f2 x2 up to fn xn. Random variable x1 x2 and x3 with the probability density as there for continuous case, that means. So find the joint probability density and evaluate the probability p of x1 plus x2 less than equals to 1, x3 greater than. There are the three variables are there. F1 of x1 equals to e to the minus x1, f2 x2 are 2 into e to the minus 2 x2, f3 x3 is 3 into e to the minus 3 x3. So what is the joint probability density? So we have to multiply. And total after multiplication 6 into e to the power minus x1 minus x2 x2 minus 3 x3. And another case is equals to 0. So if p of x1 plus x2 less than equals to 1 and x3 greater than 1. That means you have to first one x1 equals to 0 to 1 minus x2, x2 is equal to 0 to 1, x3 is equal to 1 to infinity. A similar way you have to find out the integration. Next is we have to discuss about the mathematical expectation. One by one definition. For discrete case, e of x, summation x into f of x. For continuous case, e of x, integration can be taken, minus infinity to infinity, x into f of x dx. Give suitable example. F of x equals to 4 by pi into 1 plus s square. X lies between 0 and 1 and equals to 0 otherwise. We have to find out the expected value of this random variable. Very simple, expectation of x into f of x dx integration. And 1 by 1 we have to find out minus infinity to 0, 0 to 1 and 1 to infinity. Then 1 by 1 this is 0 and the last one is 0 and the integration in the middle term, the answer is become 0.4413. Suppose x is a discrete random variable. You have to take it expectation of a g of x. G of x means a g of the function of x. Then that means a g of x into f of x summation. For continuous case, exactly integration minus infinity to infinity g of x into f of x. In the example, suppose g of x equals to 2s square plus 1. Then we have to find out the e of g of x, the summation g of x into f of x. G of x is what is that? 2s square plus 1. So 2s square plus 1 into f of x is equal to 1 by 6 and put it and answer is 94 by 3. In this connection, one theorem, very important theorem, e of ax plus b equals to a into e of x plus b. A is a constant and b is also constant. And exactly proof very simple. Left hand side you have to take it and the answer is a into e to the e of x plus b. And similar way, suppose b suppose 0. B is constant means b of suppose 0. That e of x is a into e of x. And suppose a is constant. So e of b equals to b. Very simple, very important formula. E of b equals to b. For constants, so e of c g of x equals summation c into e of g of x. And simple proof and see that proofs, and very simple. E of Ci is this and summation equals to this, and the double summation equal to this, and Ci is on left side and E of Gi x, and hence proved. F of x is given. You have to find out the expectation of s to the power r. How can you find out the e of x to the power r? Now e of x to the power r, integration minus infinity into s to the power r f of x dx, and put it s to the power r and f of x can be taken. Then after that the result is 2 by r plus 1 into r plus 2 to the power n. So the formula is nci a to the power n minus I b to the power I e of x to the power n minus I. Very important formula. Suppose e of x plus b equals how much? Now a into e of x plus b. Here x plus b whole to the power n. So that formula x plus b whole to the power, that is the binomial coefficient formula, binomial theorem. We have to take it, and the answer is become this. Very simple for proof. Joint kinds means e of g of xy. G of xy means g of xy f of xy for discrete case. And similarly continuous case, the double integration g of xy f of xy dx dy. Example for discrete random variable. Suppose f of xy equals to this much, and g of xy equals to x plus y. So how can you find out the expected value of g of xy? And we have to take it summation because discrete random variable. So e of xy, first one is suppose f of xy means f of 0 0. Next one is f of 0 1. Next one is f of 0 2. Next one is f 1 0. Next one is f 2 0. Next one is f 1 1. So the total the putting the value and get the answer. Similar way for the continuous cases, and probability density function already given, and we have to find out the expectation. And just you have to take it the integration, and you have to find out the result. Next one is moments. Moments for discrete case. E of x to the power r. Just e of x means it is the expectation of x. But e of x to the power r means you have to take it s to the power r into f of x, and that is called as a mu r dash. If r is equal to 0, say s to the power 0 f of x. R is equal to 1, s to the power 1 into f of x, and the similar way that is for discrete case for summation. For continuous case, just integration can be taken. Suppose r equals to 0, so mu 0 dash equals to e of x 0. Mu 0 1 dash equals to e of 1 equals to summation f of x. So mu 0 dash equals to e of 1 equals to 1. You have to remember must mu 0 dash. Similar way mu 1 dash x into f of x. That is the moment about the mean. Rth moment about the mean. Just rth moment means e of x to the power r. But rth moment about the mean means x minus mu whole to the power r. Then x minus mu whole to the power r into f of x. For continuous case, similar way, x minus mu whole to the power r f of x dx are just integration for continuous, and discrete case for summation. Similar way, r is equal to suppose 0. Then mu 0 equals to 1, mu 1 equals to 0, and so on. 2. So mu 2 is equal to how much? The sigma square. Sigma square variance of the distribution, and that can be taken as a v of x, or the standard deviation of whole square, and so on. And positive square root of the variance, the formula already given by the statistics, sigma equals to standard deviation, which is called the standard deviation. And many theorems are there, but one theorem is very important, that is a sigma square is equal to mu 2 dash minus mu square equals to variance of x. Suppose take it as the sigma square, that is the variance of x, that is the standard deviation square. So e of x minus mu whole square, and you have to first spread out, and then and answer becomes mu 2 dash minus mu square. Of ax plus b equals to a square into sigma square. Variance of ax plus b means sigma square ax plus b. Sigma square ax plus b means mu 2 dash minus mu. Then so mu 2 dash minus mu square. Then so e of ax plus b square, and then e of ax plus b whole square. Then so after simplification, you have to get a square into sigma square. Very important theorem. Different random variable, integer valued random variable, that is the n0. And suppose vx is equal to v1, v2 up to vn, with the range of x. Then an is equal to x of omega vn. So vn are disjoint. Suppose union of an because they are disjoint, also equals to sample space. What is the point of the expectation? So Bn into P of an. So Bn is equal, what is that? Now n, because n is the integer value, random variable, so n into P of an. Another example, Pn is equal to suppose 1 by n. What is the point of the E of x? Now summation P of n and P1, P2 up to this, and P1 means 1 by L, P2 is 1 by L, and so on. And how many times? And the L times. The answer is 1. So what is the expectation? Now n into P of n. So Pn is a constant. So summation n. Summation n means 1 plus 2 plus up to n. So what is the formula? Very simple formula. L into L plus 1 by 2. And so answer becomes function of a random variable. Suppose x is a summable random variable. How can you show the x is a summable random variable? Only the formula is x is a summable random variable. Summable means the E of mod x must be finite. And suppose x greater than or equals to 0, then E of x is a divergence. If x is bounded, then x of omega mod less than or equals to m. So x is a summable. E of x is what is the value? Now x of omega mod into P of omega, because x of omega mod is a constant, that is a less than or equals to m, and summation P of omega. Summation P of omega you know that is 1, so equals to m. So E of x must be less than or equals to m. If omega is finite, then every random variable x is bounded. Very important, that is bounded. Indicator Ia of omega. Suppose A is a subset of a sample space. So indicator of omega, one is 1, another one is 0. 1 means omega belongs to A, and omega does not belong to A, that means 0. Omega belongs to, that means A dash. Then what is the expectation? The expectation is a P of A, very simple formula. And there are properties. Indicator function means properties. Ia plus B is equal Ia plus Ib. I omega means Ia union A dash. Ia means 1 minus Ia dash. Ia equals to 1. Ia union B is equal 1 minus. Just a theoretical, just a set theory. We have to know about the Bernoulli's random variable. We say random variable, Bernoulli random variable means the probability mass function of x is must be P of 0 equals to 1 minus P, and P of 1 is equal to P. Then the total addition must be 1. 1 minus P plus P is equal to 1. So P of 0 plus P of 1 is equal to 1. Suppose x is equal to 0, suppose we say outcome is a failure. Then x is equal to 1, what is that? Now outcome is a success. Similarly, binomial random variable. Binomial random variable means P of x equals to k, mc k, p to the power k, 1 minus p whole to the power n minus k. Then so summation k is equal to 1 to n, P of x is equal to k is equal to 1. And P of x is equal to k must be greater than or equal to P of x equals to k minus 1. Then so k less than or equals to P of n plus 1. Similarly, x is a Poisson random variable with parameter lambda. Poisson random variable. P of I equals to e to the minus lambda into lambda to the power I by I factorial. Random variable, Poisson random variable means that is the formula. Suppose Poisson random variable Poisson function that means Poisson function means f of x can be taken. If mu and sigma are the mean and standard deviation of a continuous random variable x, then probability of x minus mu of mod less than k sigma greater than 1 minus k square sigma greater not equals to 0. We have to prove this. This is the Chebyshev theorem, and sigma square we have to know, expectation of x minus mu square, and because of a continuous random variable we have to take it in integration, and after that we have to take it minus infinity to mu minus k sigma, and mu minus k sigma to mu plus k sigma, and mu plus k sigma to sigma, and that greater than equals to minus mu to mu minus k sigma, mu plus k sigma to sigma, and just middle part, because of this is non-negative in mu minus k sigma to mu plus k sigma, you have to omit, and that greater than equals to minus mu to mu minus k sigma to mu plus k sigma to infinity, and after that, that implies the sigma square by k square sigma square greater than equals to this, and the probability of x minus mu whole mod greater than equals to k sigma must be less than equals to 1 by k square. Therefore, just alternate, just greater than equals to less than, then automatically less than equals to greater than equals to, because of the probability formula that equals to 1. Hence put. Function. For discrete case, mx of t, expectation of e to the power tx, e to the power exponential of power tx. And so e to the power tx into f of x summation for discrete case summation, and continuous case exactly the minus infinity to infinity, that the integration can be taken. And you know the Maclaurin series expansion, e to the power x is how much, e to the tx is how much, and so moment generative function expectation of e to the power tx can be taken as this, and the result must t with respect to t d to the power r by dtr equals to mu r dash. You have to prove this. Mxt you know. So you have to find out the first derivative. Next one is the second derivative. The next one is the rth derivative. And the result is mu r dash. In this connection one theorem, mx plus a of t. What is that? An expectation of e to the power x plus a into t. So e to the power a t is common and mxt. mbxt exactly same. mx plus a by t equals to expectation of e to the power x plus a by b into t. So e to the power a by b t is common and mx of t by b. How can you prove this? Now expectation of e of x plus a t, you have to say that mx plus a over t, and integration you have to take it, and e of xt plus a t, and so on. So e to the power xt into f of x dx into e to the power a t. And so e to the power a t is common, and this is the formula of mxt, and that equals to right hand. And similar way you have to prove these others. And the symmetry or skewness of a distribution is often measured by a quantity alpha 3 mu 3 by sigma q. And for kurtosis, alpha 4 is equal to mu 4 by sigma 4. Inequality p of x greater than equals to a less than equals to mu by a. Product moments are for discrete case mu r comma s, just two discrete random variable, you have to take it mu rs dash, and similar way the summation can be taken. For continuous case, the similar way the integration can be taken. Whenever r1 and s0, then mu 1 0 dash. Moment about means x minus mu x whole to the power r and y minus mu y whole to the power s, and that double summation can be taken. For continuous case, similar way the integration can be taken. Next one, the covariance. You have to find out first mu 1 1. Mu 1 1 you can find out e of x minus mu x into y minus mu y, and this is the formula. And the covariance of x and y, sigma xy whole mod or covariance of xy or c of xy. Theorem very important. Sigma xy is equal to mu 1 1 dash minus mu x minus into mu y. Sigma xy e of x minus mu x into y minus mu y, and that can be, you have to simplify. After that you have to get the result mu 1 1 dash minus mu x mu y and equals to RHS. And then e of xy is equal to e of x into e of y. How can you prove this? Now e of xy can be taken, and summation xy f of xy, summation xy g of x into h of y, f of xy can be transferred to g of x into h of y, and you have to separate it, and after that e of x into e of y. Similarly, sigma xy mu 1 1 dash minus mu x mu y, and it can be taken as e of xy, and after the ex into ey and ex ey and ex y, and that equals to 0, and sigma xy equals to 0. Random variables. So expectation x1 x2 up to xn, e of x1 into e of x2 into e of xn, and the proof be similar, and the summation n summations can be taken, and individual you have to take it, and after that the result will be up. Moment of linear combination means the suppose e of y equals to summation ai e of xi. Suppose y is equal to ai xi summation I equals to 1 to n. Variance similar way, ai square variance plus 2 double summation ai as a covariance, and the most important formula. Suppose example, for proof e of y equals to e of y, put the value of y, and that is common, and e of xi, and that is equal to mu y. And similar way variance of y, variance of y is equal to summation I equals to 1 to n ai square variance of xi plus 2 into double summation ai as a covariance xi xi. Similar for x1, x2 up to xn are random variable. Y1 equals to ai xi summation and y2 is summation bi xi. Then covariance y1 y2 how much? Na ai bi variance xi and double summation ai bj plus aj bi. The two n random variables are independent. So automatical double summation must be 0. And so covariance y1 y2 is equal summation I is equal 1 to n ai bi variance xi. Only double summation can be omitted. Summation ux into f of x minus y. For continuous case, integration can be taken. And for continuous random variable, suppose f of xy is the conditional probability density of y given x is equal to x up to y. The conditional expectation e of b of y minus x is equal to by into f of x minus y divided integration minus infinity to infinity. Mu x minus y equals to e of x minus y. After the very important conditional mean, after the relation, the regression and correlation, the formula can be taken. It will be similar way. Sigma square x minus y equals to e of x minus mu x minus y the whole square minus y. Distribution. Special distribution means that is for discrete case, uniform distribution can be taken. Uniform distribution, the mean can be found out and variance can be found out. Mu is equal to xi into 1 by k summation sigma square xi minus mu whole square into 1 by k. Function mxt is equal to e to the power t whole into 1 minus e to the power k t whole divided by k into 1 minus e to the t. And very easy proof, you have to see the proofs. B of x and theta is equal to nc x theta to the power x 1 minus theta whole to the power n minus x is the important formula for the binomial distribution. And binomial distribution ncx is the number of ways in which we can select x trials and which that is to be success. And n and theta are variables. In this connection, one theorem bx and theta is equal to b n minus x n 1 minus theta. You know from plus 2 level ncx is equal to nc n minus x. And we have to find out the mean and the variance from binomial distribution. Mu is equal to n theta, sigma square n theta into 1 minus theta. Very easy proof. How can you prove this? Mu is equal to, proof? Now first you have to take it mu u of x and x into b, and after that and put the value and n theta after that ui is equal to x minus 1 and m is equal to n minus 1 also equals to mu is equal to n theta. And after that the value is total is 1 because binomial distribution summation is equal to 1 and so mu is equal to n theta. Variance similar sigma square e of s square plus adding is minus x and plus x and e of x into x minus 1 e of x. And so automatically the first one is x into x minus 1 and cx theta to the power x 1 minus theta whole to the power n minus x plus mu. And after that you have to simplify. And after the simplification, n into n minus 1 theta square into 1 plus n theta, n into n minus 1 theta square into 1 plus n theta, and after that n square theta square minus n theta square plus n theta. After that sigma square is equal to mu 2 dash minus mu square and put the value n theta into 1 minus theta. Function. Factorial moment exponential expectation of a t to the power x, summation t to the power x into f of x. And you know that the derivative, rth derivative fx of t is equal to mu r dash. Expectation of y is equal to theta and sigma y square is equal to theta into 1 minus theta y n. X as a binomial distribution. Then how can you show? Now y equals to x by n. Then ny is equal to x. Then expectation ny e of x. Then n is common, e of y is equal to theta. So e of y is equal to theta. N square y square is equal to s square. So e of n square y square e of s square. N square is common, e of y square is equal to e of s square. E of y square is equal to e of s square by n square. So e of s square, you know n into n minus 1 theta square plus n theta. So e of y square similarly n into n minus 1 theta square plus n theta by n square. So sigma y square is equal to e of y square minus e square y. And to put the formula and sigma y square theta into 1 minus theta y. Similarly, the moment generating function of the binomial distribution mx of t is equal to 1 plus theta into e to the t minus 1 the whole to the power n. How can you prove this? Now first one is mxt e of e to the power tx and put the formula by binomial formula is given, and after that put in the formula 1 plus theta into e to the t minus 1 the whole to the power n. Of a binomial distribution, how can you find out the mean and variance of a binomial distribution? First you know mx of t and mu1 dash is equal to d by dt, and after that, that is called mu, and so mu is equal to n theta. So mean is equal to, we have to find out mean is equal to n theta. Similarly, mu2 dash means that is the first derivative of mx of t. So after that, the result is n theta and theta square into n sigma square is equal to mu2 dash minus mu square, and after that the result is n theta into 1 minus theta, and hence the result. And geometric distribution. The first one is the negative binomial distribution, means b star x k theta is equal to s minus 1 c k minus 1 theta to the power k whole into 1 minus theta whole to the power x minus k. For the value of x is equal to k, k plus 1, k plus 2, and so on. Sk theta is equal to k by x into b of kx theta. How can you x minus 1 c k minus the theta to the k 1 minus theta is to x minus k? After the putting the definition, and the result is k by x into b kx theta. Mean and variance of a negative binomial distribution, mean is equal to k by theta, and variance is equal to k by theta whole into 1 by theta minus distribution g of x theta is equal to theta into 1 minus theta whole to the power x minus 1, for x is equal to 1, 2, 3. Very important, that definition, g of x theta. How can we find out the Poisson and limit n tends to infinity, theta tends to 0, binomial b x n theta, and n theta is equal to lambda. From the binomial distribution, putting theta is equal to lambda by n, and so we have to take it to binomial distribution in c case and so on. And after that, putting the limit n tends to infinity, we get the x lambda is equal to lambda to the power x whole into e to the power minus lambda by x factorial. Very important, that is a Poisson distribution. Distribution will provide a good approximation to binomial distribution. When n greater than 100, n theta less than 10, we prove that the Poisson distribution will provide excellent approximation to binomial distribution. And so this is called as also Poisson limit law. Poisson limit law means limit n tends to b x and lambda by n is equal to Poisson distribution. Similar way, other way भी, other books भी. This is called as a Poisson limit law. Limit n tends to b x and lambda by n is equal to Poisson formula, that is a Poisson distribution formula. And also other books we can be referred to b k n p equal to pi k lambda. And pi k lambda means k belongs to n0 integer valued random variable, and that is a n0, and that it can be taken as a x, taken as k, and the x and k can be the same for that. Binomial ratio means bx and theta, bx plus 1. What is the value? The lambda by k plus 1. Similarly, a Poisson paradigm, and so mu is equal to summation pi, I is equal to 1 to n. And the ratio of conjugative terms, p of x is equal to x plus 1 by p of x is equal to exactly value lambda by x plus 1. Mean and the variance of a Poisson distribution. Mean is equal to lambda, variance be also lambda. How can you prove that? And e of x is equal to x into Poisson, and so put the formula and get the answer, mu is equal to lambda. And similarly, a variance sigma square, and put mu2 dash minus mu square, e of s square mu square, and put the formula, and have to get the e of x into x minus 1 is equal to lambda square, and now the sigma square is equal to this e of x into x minus 1 plus e of x minus mu square. So lambda square plus lambda minus mu square, lambda square equals to lambda. And after that, find out the moment generating function. Similarly, e to the lambda into e to the t minus 1. The lambda into e to the t minus 1. And the mean and variance of a Poisson distribution from moment generating function. First, you know moment generating function e to the lambda into e to the t minus 1. So mu equals to mu1 dash. You have to first derivative must be mx dash of 0. And lambda into e to the t, e to the lambda, e to the t minus 1. First derivative, and put the 0. And mu is equal to lambda. Similarly, second derivative you have to find out, and again put the value of 0. And so mu2 dash is lambda plus lambda square, and sigma square is equal to mu2 dash minus mu square, and put the value equals to lambda. Densities. Introduction and the uniform distribution. What is the uniform distribution? U of x alpha beta 1 by beta minus alpha, for x lies between alpha and beta, and 0 elsewhere. And this is the graph, and alpha and beta, and 1 by beta minus alpha, and just as this alpha to beta, and this is a purely, that is a step function. And mean and variance, mu usual alpha plus beta by 12, sigma square 1 by 12, beta minus alpha square. Uniform distribution, mean and variance, you have to remember, and proof be also taken. That is mu1 dash e of x, and put the formula, and mu is equal to alpha plus beta by 2 or beta plus alpha by 2. And similar way variance and mu 2 dash minus mu square, and after that 1 by 12 beta minus alpha whole square. Chi-square distribution. The first one, the f of x will k into s to the alpha minus 1 e to the minus x by beta x greater than 0, another 0, and that is also here. And we have to integrate f of x, and that equals to k into beta to the alpha tau alpha. Tau alpha is a gamma function. That means the properties of gamma function, the tau of 1 must be 1 first, and the tau of alpha is equal alpha minus 1 factorial, tau alpha alpha minus 1 into tau of alpha minus 1, and tau of half is equal to pi root over. So area must be equals to 1, you know, and so k is equal to 1 by beta to the alpha tau alpha. So the k value must be, you have to remember, 1 by beta to the alpha tau alpha. Distribution means g of x alpha beta 1 by beta to the alpha tau alpha s to the alpha minus 1 e to the minus x by beta. What is the k value? We have to put it. And there is a very important probability distribution, probability density function. That is a purely continuous random variable. And special case of gamma distribution, alpha is equal to 1 and beta is equal to suppose theta. So g of x1 theta 1 by beta into tau 1 x to the 0, and that value 1 by beta into 1 e to the minus x by theta. And exponential distribution, g of x theta 1 by theta e to the minus x by theta for x greater than, remember that formula, and equals to 0 else theta greater than 0. Must be the graph is this 1 by theta, x is equal to 1 by theta. And probability density of continuous random f of y equal p of y less than equals to y. So what is the value? Now 1 minus this and 1 minus e to the minus alpha y greater than 0, and y less than equal to 0. And so probability density of y, f of y, first derivative can be done, if this, so to of alpha into e to the minus alpha y greater than 0, 0 and elsewhere. Another one is a chi-square distribution. Chi-square f of x is equal 1 by 2 to the power psi by 2 into tau psi by 2, and x to the power psi by 2 minus 1 e to the minus x by 2 for x greater than 0, another 0 elsewhere. X is gamma. For gamma distribution, how can you find out the moment about the origin? Mu r dash is equal to this formula. How to find out the moment about the origin? Now mu r dash is e to the s r, and you have to take as the integration because continuous random variable, and put the formula, and beta to the r tau alpha plus r whole divided by tau alpha. Find out the mean and variance of gamma. Mu is equal to alpha beta, and sigma square equals to alpha beta square. We have to prove this mu 1 dash is equal to alpha beta, and mu 2 dash is equal to alpha into alpha plus beta square. So we have to find out the sigma square variance. So mu 2 dash minus mu square, the answer is alpha beta square. Distribution similar, mu equals to theta and sigma square is equal to theta square. And mu is equal to alpha beta 1 into theta is equal to theta, and sigma square alpha beta square 1 theta square equal to theta square, because alpha is equal to 1 and beta is equal to theta. Mean and variance of chi-square distribution. Chi-square mean is equal to mu is equal to psi, and sigma square is equal to 2 psi. For chi-square mu is equal to alpha beta, psi by 2 is equal to psi. Psi by 2 into 4, and that is 2 psi. Moment generating function of a gamma distribution. How can you find out the moment generating function? mxt equals to 1 minus beta t whole to the power minus alpha. First e to the tx, also e to the tx, and that is the gamma distribution function g of x alpha beta, and g of x alpha beta, put the definition, and that equals to, you have to find out the integration, and definitely the integration, you know, just to put the y into 1 minus beta t is equal to z, 1 minus beta t dy is equal to dz, and tau alpha minus 1 minus beta t is equal to this much. So that put the formula 1 minus beta t to 1 minus alpha by tau alpha by 1 minus beta t. So automatically tau alpha cancel, and after that 1 minus beta t to whole to the power minus alpha. Function of the gamma distribution function 1 by 1, mu 1 dash, mu 2 dash, and sigma square. And mu 1 dash is equal to alpha beta, mu 2 dash is equal to alpha beta square into alpha plus 1, sigma square is equal to alpha beta square. Beta distribution, next one is the beta distribution. Beta distribution formula very easy, and that is f of x is equal to 1 and 0, x is equal to 1, x lies between 0 and 1, 0 elsewhere. And so random variable beta distribution, the probability density function is equal to f of x to tau alpha plus beta by tau alpha into tau beta into x to the alpha minus 1 minus x into beta to the power beta minus 1 and equals to 0 elsewhere. Now, how can you find out the mean and variance of a beta distribution? How can you find out the mean and variance of distribution? From mu is equal alpha by alpha plus beta, sigma square is equal alpha beta by alpha beta whole square whole into alpha plus beta plus 1. Expectation we have to find out, that is alpha by alpha plus beta, and the second one mu 2 dash, and the next one is a sigma square, that is a variance. The next one mu 2 dash minus mu square. After that the result is alpha beta by alpha plus beta whole square, alpha plus beta plus 1. And Cauchy distribution, f of x, Cauchy distribution, the probability density is f of x beta by pi whole divided by x minus alpha square plus beta square. X belongs to R. And mu1 dash and mu2 dash does not exist. For the Cauchy distribution, mu1 dash and mu2 dash does not exist. Rayleigh distribution, f of x is equal to this formula. Very important formula, you have to remember f of x 2 alpha x into e to the minus alpha square, x greater than 0 and 0 elsewhere. Alpha greater than 0. Distribution mean is equal to half into pi by alpha whole root over, and sigma square variance is equal to 1 by alpha whole into 1 minus pi by 4. And Pareto distribution, f of x is equal to this much. F of x is equal to alpha by x to the power alpha plus 1, x greater than 1 and 0 elsewhere, alpha greater than 0. Properties mu1 dash exist only if r less than alpha, and mean is equal to alpha by alpha plus 1. Weibull distribution, f of x is equal to k into s to the power beta minus 1 e to the power minus alpha s to the power beta, x greater than 0 and equal to 0 elsewhere, alpha is greater than 0, beta will also greater than 0, and k is equal to alpha beta, and we have to find out the k the similar way that last one they read, and k is equal to alpha beta and mu is equal to alpha to the power minus 1 by beta tau 1 plus 1 by beta. N of x mu sigma 1 by sigma 2 pi root over e to the power minus of x minus mu by sigma whole square. X belongs to R, sigma greater than 0, mu and sigma are parameters, and mu must be belongs to R. If mu is 0 and sigma 1, that is a normal distribution, and there must be this is a 0.399, and mu sigma square is if arbitrary, then 0.399 by sigma, because sigma is arbitrary. So this is the normal distribution graph. Normal distribution is a probability density function, and that means you have to prove that f of x greater than 0 and must be 1. So you have to prove the integration equals to 1, integration, put the formula, and after that you take it dz is less minus mu by sigma, sigma dz equals to dx. After that the root over tau half, so that equals to 1. And how can you find out the moment generating function? The moment is e to the power mu t plus a half sigma square t square. We have to prove this. How can you prove this? Now, so mx is equal to e of t to the e to the power st, and you have to take it integration because it is a continuous random variable, and put the formula, and after that this 1 by sigma 2 pi root over minus infinity to infinity e to the power minus 2 by sigma square x minus mu square whole square into plus xt dx. Before that integration, first you have to simplify x minus mu whole square minus 2 sigma square xt, and after that the result is x minus mu plus t sigma square the whole square minus 2 sigma square mu t plus a half t square sigma square. After that the put the formula mxt is equal to 1 by sigma by 2 pi root over sigma minus infinity to infinity e to the power minus half into this. So after that you have to put the x minus mu plus t sigma square, automatically ds is equal to sigma z, all are the other are parameters. And after that put the formula, and 1 by pi root over into pi root over equals to 1. And so mx t is equal to e to the mu t plus half sigma square t square. Similarly mx, you have to find out the derivative, first derivative, second derivative, and ms dash 0, ms double dash 0, and so on. This mu is equal to 0 and sigma is equal to 1. So normal distribution equals to 1 by 2 pi root over e to the minus half s square. What is the meaning of the standard normal distribution? The standard normal distribution means that mu is equal to 0 and sigma is equal to 1, also reported as the standard normal distribution. Mu 0 and sigma 1. So automatically 1 by 2 pi root over e to the minus half s square is the standard normal distribution. And the area you have to find out. How can you find out? Suppose the interval. Suppose I is equal to minus infinity to infinity. So double I you have to multiply. So automatically double integration. So I square is equal to this, and put x is equal to r sin theta, y is equal to r cos theta. So automatically tan theta x by y and ds dy r dr d theta, and put the formula, and the answer is 2 pi. I is equal to 2 pi. Theorem: z is equal to x minus mu by sigma as the standard normal distribution if the mean is equal to mu and the standard deviation sigma. How can you prove that? P of x1 x lies between x1 and x2, and must be the P of z lies between z1 and z2. Theorem is there. X is a random variable having a binomial distribution with the parameter n theta. The moment generating function of a z x minus theta by n theta whole into 1 minus theta whole root over approaches to the standard normal distribution when n tends to infinity. That means the proof that limit n tends to infinity mz of t will be mx of t, and p theta q 1 minus theta x lies between 0 to n and z is equal to this. Well, how can you prove this? Very easy proof. And mz t, and you have to put the logarithm on both sides, and after that ln 1 plus x formula you have to take it, can be done, take it, and after that the result, the limit is mu by sigma t e to the t square by 2, and from 3 and 4 and the mx e to the t square by 2 mx t, where x is a standard normal bivariate normal distribution. F of xy can be taken. F of xy can be taken e to the power minus 1 by 2 into 1 minus rho square whole into x minus mu 1 by sigma 1 square minus 2 sigma x minus mu 1 by sigma 1 y minus mu 2 by the whole square. Mu 1 is the mean of x, mu 2 is the mean of y, sigma 1 is standard deviation of x, sigma 2 is the standard deviation of y, rho is the correlation coefficient. Also therefore the covariance of xy is equal to rho into sigma 1 into sigma 2. When y have a bivariate normal distribution, then the conditional density of y given x equal to x is given by mu y minus x equal to mu 2 plus rho sigma 2 by sigma 1 x minus mu 1. Very important. And variance is equal to sigma square y by x y minus x sigma 2 square whole into 1 minus sigma square. And that is the most important. The correlation regression formula can be taken, must be this formula you have to take it. Mu 1 rho sigma 1 by 0 y minus mu 2, and variance sigma 1 the square is whole into 1 minus sigma square. Uncorrelated the rho is equal to 0. Correlation, similar way, we have to find out the regression of x, y, on this case the regression curve, and we have to first have the marginal density of x is equal to g of x e to the minus x is greater than 0 and equals to 0 also. So we have to find out the first marginal density g of x, and that is equal to the minus x. After that the mu y by x, that is a regression coefficient, can be regression to determine the conditional mean mu y by y minus x. That means minus x is alpha plus beta x. In this case, and this is the formula you already known, and equal to 0, and that does not depend on the x mu y minus x, above mu x minus y does not depend on y. Rho is equal to 0, sigma 1 2 is equal to 0, random variable of x and y are square. Method of least square means alpha beta and the regression coefficient have to be estimated by the method of least square. We have to find out the estimation value alpha and beta. Suppose the estimation value alpha bar and beta bar, and you have to find out the, how can you find out the alpha bar and beta bar? And very easy, and you have to del q by del alpha bar and del q by del beta bar equals to 0, and after that alpha bar and beta bar you have to find out. This means the estimate of sigma is how much the value, and the sampling distribution of a beta bar we have to find out, and variance of a beta bar. This analysis that t can be taken as this much, and normal correlation with the 5 parameters. So estimate of 5 parameters, so you have to del ln L by del mu 1, del ln L by del mu 2, and the similar way for with respect to sigma 1, sigma 2, rho must be 0, and after that the estimations are this sigma 1 bar and sigma 2 bar and rho bar. X greater than equals to a less than equal to e of x by a. You have to prove this. How can you prove? Now e of x is can be taken as greater than a into p of x greater than equals to a, and after that p of x greater than less than e of x by sub inequality p of x minus mu of mod greater than equals to k less than sigma square by k square, and that prove this. In the random sample means x1 is independent and identically distributed random variable, and they can consider random sample mean we have to find out, and that from the population mean can be found out of the mean. So E of x bar is equal to mu and variance of x bar is equal to sigma square by L, and E of x bar equal to, you have to find out E of this, and that equals to mu square by L. Strong law of large number x1 x2 are the sequence of independent random variables. E of xi is equal to mu with the probability suppose 1. So total x1 plus x2 plus n by n tends to mu, the x tends to mu, n tends to infinity. And limit n tends to infinity 1 minus sigma square n c square equals to 1. Central limit theorem of P of x1 x2 plus x2 xn minus n mu whole divided by sigma n root over less than equals to a tends to 1 by 2 pi root over integration minus infinity to a e to the minus s square by 2 dx again tends to infinity. Central limit theorem. After the result, the final the coefficient pq is a constant times on this, and general r greater than 50, the coefficient of 2r is a constant times 1 by n to the r minus 2 the whole root over. By sigma x bar is that equal to 10 to 1 by 2 by root over minus infinity to e to the minus s square by 2 dx. Next one is the normal approximation to the manual distribution. And we are very simple. Moment generating function of x1 plus x2 up to xn by root n. We have to find out e to the power exponential of this, and so 1 by 1 we have to put the formula and 1 plus t square by 2n whole to the power n. What is that? Markov chain. The properties of pi is greater than equal to 0, summation pi is equals to 1, which is in the form of this. That is called Markov chain. And forecasting the weather is one example. System, the three-state Markov chain, P and this. Model P I plus 1 is equal to P and 1 minus P I minus 1, I is equal to 0 plus minus 1 and so on. And gambling model and P I plus 1 is equal to P and 1 minus P I minus 1, I is equal to 1 to up to n minus 1. Next one is the Chapman-Kolmogorov equations. P I j n equal to P of x n plus k equals j minus xk equals to I, n greater than equal to 0, I j greater than equal to 0. But Pij equals to Pij may be power is 1 and may not be 1. So Pij n plus m equals to summation k is equal to 0 to infinity Pik to whole to the power n, Pkj whole to the power n for all n m greater than equal to all ij. It is a purely matrix form. How can you prove this? Pij n plus m, you have to prove this xn plus m equals to j minus x0 equals to I, and that way P of xn plus m equals to j, xn equals to k minus x0 equals to I, and after that summation P xn plus m equals to j minus xn equals to k, x0 is equal to I into P of xn equals to k minus x0 is equal to I, and after that the result is this. If notation, suppose Pij n can be taken as a Pn, then what is the property? Pn plus m equal to Pn into P. 1 plus 1, P into P is equal to P square, Pn is equal to Pn minus 1 plus 1, Pn minus 1 into P is equal to P to the power n. One step transition probability, P is equal to, suppose this P square can be found out, P4 can be found out, and so on, P00 equals to 0.5749. That is Chapman-Kolmogorov equation. My advice is that for the students and for the readers, definitely the part probability part B is very important for the all, and for the plus 2 level to up to PhD levels, and the research scholar is very important for that YouTube my channel. So you have to remember the most important is you have to one by one you have to discussion is here. So therefore you follow my notes and different examples, and from the many books, and the very important books is the Sheldon M. Roach and Miller books. And thank you very much.